Hi, before we look at the objective of today's lesson, here's a quick retrieval. What is meant by the term oxidation? What is meant by the term reduction? Why is potassium more reactive than copper? Why is gold less reactive than magnesium? And how do group 1 metal react with water? So you can pause the video and have a go at these 5 questions. Okay, let's have a quick look at these. The term oxidation is where oxygen has been added and it's where electrons are being lost. What is meant by reduction? It's where oxygen is being lost and electrons are being added. Gaining electrons. Oxidation is losing electrons. Reduction is gain in electrons. Why is potassium more reactive than copper? Because potassium will easily lose its electrons compared to copper in a chemical reaction. Why is gold less reactive than magnesium? It's the opposite, it's vice versa. Gold is highly unlikely or less likely than magnesium to lose its electrons in a chemical reaction. And how do group 1 metal react in water? They react quite violently, actually, producing hydrogen gas and an alkaline solution. If we look at today's lesson, reduction of metal oxides, and what we need to do, explain how metals less reactive than carbon can be extracted from their oxides, and identify the substances which are oxidized or reduced in terms of gain or loss of electrons. Now, don't forget, oxidation is loss of electrons, reduction is gain of electrons. But if we move on, have a look at these. What is the difference between these two metals? You can pause the video, think about this. Now let's have a look. What did you write? Gold is a native metal. Native means it doesn't react with anything. It's uncombined. It's unreactive, so it's found as a pure substance. Whereas copper, like most other metals, is found as a compound. A metal compound is called an ore, so it needs to be reacted with something else to extract it. Here is a quick recap of the reactivity series. You can see that there. And there's carbon and there's hydrogen, the two non-metals. Most reactive at the top, least reactive at the bottom. How could we remove the copper from copper oxide using carbon? Think about this one. So think about displacement reactions. An extension, which other metal oxides would this work for? Okay, so which other metal oxide would react with carbon? Then move on. So this is a quick recap. Oxidation is loss of electrons, reduction is gain of electrons. So you've got copper here, bonded to oxygen, ionic bonding, and what you end up with, the element copper. You've got carbon here, the element carbon. It joins up with oxygen to form carbon dioxide. So oxygen is being added to carbon to make carbon dioxide, and that's covalent bonding. So if we move on, copy each word and symbol equation and then describe which substances are oxidized and which are reduced in terms of gain or loss of electrons. If I quickly go back to this, copper is gaining electrons to become the element copper. Carbon is gaining oxygen to make carbon dioxide. If we go back to this, have a go at this, then pause the video. So again, copy the symbol equation and then describe which substances are oxidized and which are reduced in terms of gain or loss of electrons. Pause the video here. Let's have a look. How did you get on? So the first one, you've got iron oxide plus carbon gives you iron plus carbon dioxide. So the iron in iron oxide gains the electrons to become an element, iron. So if it's gaining electrons, we say the iron oxide is reduced. It's losing oxygen also. The carbon that loses electrons and forms a covalent bond with oxygen, the carbon is oxidized. It's gaining oxygen. The next one, if you look at this one, tin oxide with carbon. The next one, lead oxide with carbon. And here's some exam questions for you. One step in the manufacture of lead is a reduction of lead oxide with carbon. Lead and carbon dioxide are products of this reaction. Write a word equation for this reaction. That's worth 1 mark, and then what's it meant by reduction? Pause the video and have a go. What you should have got, there's your word equation. Lead oxide plus carbon produces lead and carbon dioxide. And the term reduction, oxygen is being lost or electrons are gained. 1 mark. If we move on. A student was trying to extract the metals from lead oxide and aluminium oxide. She heated each oxide with carbon in a fume cupboard as shown below. She was able to extract lead from lead oxide, but not aluminium. Explain the results of these experiments. Worth 3 marks. Pause the video here. Let's see how you got on. So, carbon is above lead in the reactivity series, but it is below aluminium. This means that carbon can displace the lead because it's more reactive than lead, but it's unable to displace aluminium because it's less reactive than aluminium. So carbon can reduce the lead oxide, but it can't reduce the aluminium oxide, and that's worth 3 marks. Here's another one. Complete this word equation for the reaction between lead oxide and carbon, worth 2 marks. Once again, you can pause the video here. Let's have a look. So lead oxide plus carbon gives you lead and carbon dioxide. Here you have a pie chart showing the percentage by mass of each metal in Nordic gold. You've got 89% copper, 1% tin, 5% zinc, and the remaining aluminium. Calculate the percentage of aluminium. You are supposed to find that out. It's worth 1 mark. What you should have got was 5%. We'll move on. The 50 euro cent coin has a mass of 7 grams. Calculate the mass of zinc in this coin, worth 2 marks. You can pause the video here. What you should have got, there you go. So 5% is 0.05. Times that by 7 grams, 0.35 grams is the answer. If we move on, zinc is extracted by removing oxygen from zinc oxide. What name is given to a reaction in which oxygen is removed from a substance? 1 mark. And how do we extract zinc from zinc oxide? That's 2 marks. Pause the video here and have a go. So let's see how you got on. Yep, the name given to a reaction in which oxygen is removed is reduction. And then how do we extract zinc from zinc? Heat with a more reactive element, carbon. Carbon being more reactive, it will displace the zinc from zinc oxide.